Hello everyone, this is Dr. Speights with math videos on PowerPoint. This lesson covers completing the square. Now in previous sections we've covered various methods for solving quadratic equations. Now if an equation can be factored, the most efficient way to solve would be to use the zero factor property. However, if the equation cannot be factored, then we can certainly use the completing the square method. Completing the square method allows us to solve any quadratic equation. Now, before we begin, let's discuss a perfect square trinomial. Now, a trinomial is a perfect square trinomial if it factors into a square of a binomial. So here's proof on how you can tell whether you have a perfect square trinomial or not. If the first term and the last term in a trinomial are perfect squares, and if the middle term is plus or minus twice the product of their square roots, then you have a perfect square trinomial. So here's what I'm talking about. If I take the first and the last term and take the square root of them, the square root of x squared is x. The square root of 49 is 7. If I take their answer here and multiply that with the number 2, and if it gives me my middle term, which it does, then this is a perfect square trinomial. It simply factors into the result of these two first and last square root, which is x and the 7. And in terms of what sign goes inside the binomial, it would be whatever the sign of the term just behind the square term. So in other words, when you factor this, it's going to factor into x plus 7 squared. Before we begin completing the square process, let's practice finding the value of c, the constant, or what we call the last term in a perfect square trinomial. So in completing this chart, if you look at the first two terms, what you have is the squared terms. So first thing you're going to do is look at the second term. In this case is 16, and say what's half of 16. Half of 16 is 8. Now square that. 8 squared means 8 times 8, which is 64. So therefore that means that 64 is the value of the constant, the last term of the perfect square trinomial. And recall, when we factor it, it's going to factor into the result of the square root of the first and the last term. So the square root of x squared again is x. The square root of 64 is 8. So it's going to factor into x plus 8. Remember, this determines your sign. So it factors into x plus 8 squared. Let's do the next one. The next one, we look again at the second term. This is a 10, and we say what's half of 10? Half of 10 is 5. Square that. We have 5 times 5, which gives me a value of 25. So 25 is the last term to complete the perfect square trinomial. And again, as far as how it factors, if you look at the first and the last term, the square root of x squared is x. The square root of 25 is 5. Therefore, this is going to factor into x plus 5 squared. Last row, here we see 6. Don't forget about the sign, just look at the number. And we say what's half of 6? Half of 6 is 3. Square that. 3 squared means 3 times 3, which is 9. So therefore 9 is the number of the last term in the perfect square trinomial. And as far as what it factors into, remember the square root of x squared is x. The square root of 9 is 3. This determines the sign inside the factored form, so it factors into x minus 3 squared. Next, let's go over the rules for completing the square. To solve an equation in the form of ax squared plus bx plus c equals 0, standard form, where a is not equal to 0, by completing the square, you would use the following steps. Step 1. So if a does not equal to 1, in other words, the coefficient of the first term, if it's some number other than 1, the first thing you would need to do is to divide both sides of the equation by that coefficient, because you need to make sure that you have the squared term by itself, just x squared, no other coefficient in front of it. The next step then is to rewrite the equation so that you'll have the constant term on the right side, and then you'll have the x's, those terms that have the variables in them, they will be on the left side of the equality symbol. Step 3, square half of the coefficient of x, and then add this square to each side of the equation. Step 4, factor the resulting trinomial as a perfect square and combine like terms on the other side. Last step then is to use the square root property to complete the solution. Okay, so let's begin. Example 1, solve by completing the square. So notice this particular problem, x squared minus 2x minus 4 equals 0. This equation is in standard form. So the first thing we need to do is to isolate the variables and have them on the left side. So remember that table we just completed where we had just the x squared term and another x term on, that was the first column in that table. So that is the first thing you need to do, is to make sure that those two terms are on a side by themselves, and your constant term, we want to move that over to the right side. So to do that, what we would need to do is to go ahead and add 4 to each side. Once we do that, we now have it in the form where we're ready to start the completing square process. So recall that you're going to look at this second term here, and you're going to say, what's half of 2? Half of 2 is 1. Square that. So 1 squared equals 1. So that means that we're going to add 1 to each side of the equation. Why do we do that? Well, recall the rules for equations. Whatever you do to one side, you must also do to the other side. Now, the next step in the process is to factor the left side and combine the terms on the right side of the equation. So if we look at the left side, that is a perfect square trinomial. Recall, in a perfect square trinomial, to factor it, all you have to do is find the square root of the first term. So the square root of x squared is x. Find the square root of the last term. The square root of 1 is 1. This determines their sign. So therefore, the left side factors into x minus 1 squared. On the right side, we simply need to just add 4 and 1. That's going to give us 5. So our answer is x minus 1 squared equals 5. Now from this point on, we can apply the square root property. Recall that the square root property is whenever you have a squared term on one side of the equation all by itself and a constant on the other side, remember we can apply the square root principle, which states that we need to take the square root of both sides. Now that process of having a squared number and then taking the square root of a number, They both cancel each other out, and it allows you to bring down the terms by themselves. In other words, where we will bring down x minus 1, and on the right side, since the square root of 5 is not perfect and it does not have a perfect inside of it, we must leave it underneath the radical symbol. So that's going to give us x minus 1 on the left side and plus or minus square root of 5 on the right side. Because remember, when you're using the square root property, it's very important that we use the plus or minus symbol as part of our answer, because we have two solutions. Last step to solving for x then is to add 1 to each side, and x equals 1 plus or minus square root of 5.